Alright, so welcome back now to another video on Node.js. Okay, so after I went through all of the different models in Node, where I look at the fundamental, the architectural, the model system, the input and output, sorry, and also the how to build a web server from scratch, how useful and easy is to use a web server framework such as Express to do that. Also, how can create a real life example and see things like testing, unit integrations, and E2E testings. Also, uh, see how you can scale your applications using clusters, how to persist the state of your application outside of the server using a database, and an overview of database landscape on the industry from the IBM blog post that talk about that, an overview of the database landscape, where in there I look at the different license, the restricted and open source license, and the spectrum of this last one. Also, database map to license, whether it is RabbitMQ to a public license, and for example, Apache Cassandra for a Apache license, Redis, which is used now in a Pharaoh GPL 3 version, and more proprietary license like Oracle or IBM, as well as that they are proprietary. Okay, and also I see is the five most common family in that industry, whether it's the relational database, key value, document base, graph, and white code. Also, how can I use Mongo, this document based database from Mongo Atlas, and connect to a web server application and perform a basic crew operations. Also, I saw how can I version our API, especially if you're going to serve to different type of end device, whether it's a laptop, mobile, desktop, or any of the IoT. Then, how to secure your applications uh, and the authorization and authentication mechanism. So the way to secure your application is setting an HTTPS, for example, establish that secure channel across the server and the client, and also use tools or use NPM tools that secure your header, so that you only send relevant information and protects against other vulnerabilities. Again, that NPM package called Helmet is not a bulletproof, but it can help. Also, you have is the authorization and authentication methods. So the distinction between the authentication, which checks which when a user check if the user credentials exist on the database, that's authentication. And authorization is that once a user is authenticated, then send or allow access to different part of your service. There are several ways of you can do that. So for example, cookie based, GW or this token based authentication, or the OAuth 2 methods, right? I also see how can I implement all of these different authorizations approach. And for example, in the case of OAuth, that comes with different uh, authorization providers or authorization vendors, whether it's Twitter, Google, Amazon, Apple. So Passport allows to simplify all of this in one single package where we can just by adding plugins decide which authorization mechanisms or approach and vendor we want to use, right? I also saw how can I set up a cookie-based authorization on the client side and on the server side, okay? And how to secure your keys, especially. So then I saw how can I set up a CI/CD server, and this is something especially and crucial for teams to collaborate or to integrate code into the same shared repository that can be or that is used to after a certain accepting criteria deploy that into production. So we have that is continuous integration, and that is a particular step on the entire flow of continuous integration, continuous delivery, and deployment. All right. So CI is the first step. What you define is a set of practice, developer practice, to integrate for code integration, like the build step and the test step. The accepting criteria, which comes from the continuous delivery, are usually run by quality assurance teams where they set a couple accepting criteria before you can deploy to production. And then you have the continuous delivery, and most continuous developers have some conflict, or they may want to apply that continuous delivery to all process or to any industry. So for example, in the case of building a chat application or a software application, that might be the way to go. But for other industries, such as the healthcare, where you need a very well battled test application, because you don't want a bug, for example, in a heart device, in a heart rate device. Uh, so it's something to consider. I saw how can I create this workflow using GitHub Actions that provide us a CI server where we can define is this workflow as a YAML file when you set up the uh, uh, based on which events you want to listen, set a particular job to run behind the scenes, right? This is when you define as a build step, and you're setting criteria of that, also the test, and for example, you want to mock a database in a CI/CD server using the GitHub Actions from the GitHub Actions marketplace, where you can run a database in that CI/CD server, import data from productions inside of this, and test, make your, for example, integration tests much more feasible and reliable to production, right? On your staging environment. So that's cool. That's cool. It's also important to understand that. Um, Once I know that, okay, uh, then I look at how to deploy your server, okay? Because yeah, how when you can deploy your application. So using things, uh, so using things like um, mhm. So using things like mm, or here on the deployment, I mean, is with no deployment in production using AWS in our case. So I saw the different mechanism on how to do that. First, using the serverless approach, which even though that the name might be a little bit deceiving, because after all you have a server, but you don't take care of the management aspect or the creation or monitoring aspect of maintaining a server. You only need to know is when this code will run and what it does, right? Even though this approach can come with some trade-off, because if you're not careful on how you set up your serverless architecture, you can increase the latency of your entire app. So that's one of the trade-offs. Uh, and the reason is because the once you deploy your server code to a serverless, for example, AWS Lambda, and if that server go to sleep, you need to wait for that server to restart before handling requests. So this is one consideration. And the other is that you might lock in yourself with a single cloud provider, so making a migration something hugely costly. So that's some of the CTO or CIO decision. Yeah, this chief engineering officer, this chief data officers, what they need to make that decision with that. But in any case, okay. Uh, since after that, then I look at the other another approach, which is on premise on the physical servers. You can go or with virtual machines or the containers. Now, virtual machines are uh, a a machine run on top of another machine. So the architecture here, or the architecture design is you have the infrastructure where this is when you have your laptop, your physical server, and on top of that you have something called the hypervisor, which is a piece of software or hardware in the case of mobile that manage the creation of your guest OS, which runs on top of the hypervisor, right? So this approach is something that is very secure because applications that run inside of this is guest OS don't have communication with other guest OS, right? So this is self-contained, truly self-contained, whether in the Docker approach, because this architecture is what is more uh, lean in terms of you have the infrastructure. On top of that, you have your OS or the system, and on side or on top of the OS, you have is the Docker software running your containers, right? The issue here is that because even though that is each container provides stronger isolation, it's not that it's not a guarantee that they might find a loophole to communicate across different containers, right? Especially because they're running on top of the OS, rather than be that each one of those applications run on its self-contained OS, right? The trade-off is with container, even though that is less secure than virtual machines, it is much more uh, efficient in terms of space. In any case, it's a trade-off that you need to consider. So we choose is even though the Docker approach uh, and uh, then I saw how can I create like a container, a Docker file, then how containerize an application with Docker, and with Docker Composer allows to run multiple servers, and how can we push our container instance into the Docker registry or Docker Hub, similar as GitHub, Docker Hub. So once we get access to the EC2 instance from the Amazon, okay, what they provide us is a access to a virtual machines, and they have a hypervisor highly optimized for that architecture. Once we can gain access to that, uh, we can then pull from the Docker Hub or Docker registry and run that. And that's exactly what we did. And it was pretty amazing how easy it is. Uh, and then I look at GraphQL. So GraphQL is a new way of building frontend and backend. It's a new query language. That the beauty of it is that we can see how different data or piece of data relate in a server. So it all started by describing is the data using schemas, uh, and mhm. Yeah, it all start by describing your data using schema, and when you want to ask for data, use GraphQL queries. So these queries is much like selecting property on an object. And the beauty of this is because the query really match close to what the return object will get, we can predict what our query will return, including all the properties, regardless how the data is stored in the backend. And we will get a JSON object. So yeah, we will get a JSON. So that's great because then I look at who made that uh, Facebook in 2012. I look at the specifications, the GraphQL client side using or use on the React framework, such as Relay.dev, and more high-end product like Apollo. So before looking at that, I dive deep into how to create a GraphQL server from scratch, and uh, using the node for that and npm package like GraphQL tools that allow us to create our first GraphQL from scratch. And C is the type system where we define all the capability of this GraphQL will have. Now a more realistic uh, project designing an e-commerce to see two things, right? Two things. First, how can we modularize our applications or GraphQL servers using or how can we modularize our server for schema and resolvers? What is resolvers? Which is the function that determine when it's a function that determines the value of a property when a valid GraphQL is made in our GraphQL server, right? And also see how can I define is this uh, modularized way of defining schemas using is the GraphQL file where you're going to define is all of these different root level operations, whether it's the query or mutations along all the other types relevant to that feature. Okay, and then the resolvers, which you want to make that as small and thin as possible, and let the API calls be handled by the data access layer file, right? And that was pretty interesting and pretty cool, by the way. How you can define instead of a resolver is the queries and the mutations, and also see the reason of mutations, because in GraphQL assume, or not GraphQL, in any API, the most common operation you will ever do, or the most likely common operation you will ever do, is the uh, reading or gathering data. Okay, so because of that, right? GraphQL is very good on doing queries. So what about the other type of operations? So for example, when you want to take the data, when you want to create, update, or delete that data, you use mutations for that. And I saw how can I implement that, and how you can send parameter in a queries and in a mutation, and how to perform several mutations at once. And then I look at Apollo, which is this GraphQL. This is an industry standard GraphQL implementation that provide the data graph layer to connect mother web apps to the cloud, right? So they come with they come with a lot of features, like the Apollo client, Apollo server, the Apollo federations, the LAN CLI rover. If you want to really commit to their platform to build a greater GraphQL project as part of a much larger team, but most of the time we're going to use this Apollo and Apollo client and Apollo server, right? So because of that, I saw what is an Apollo client, which is a set of front-end libraries that allow us is to create queries and save data. So much like you will do with graphical, this built-in browser front-end tool to test queries, GraphQL queries, and it also comes with other benefits, such as uh, catching, handling, loading, and error state, and the keep your data synced with the server. So that's Apollo client, and the Apollo server, okay, allows you to build a GraphQL server in Node, and also provide a couple of things like deploy and run your server code in a serverless environment such as Lambda, and implement subscriptions, which is another two root level operations in GraphQL that is another root level operation in GraphQL where the server send message or push message to subscriber client, much like push notification. So then I look at how can I create, or in this case, how can I add Apollo into an existing Express GraphQL server. And it was very easy to do that because, well, we modularized our server so well that it was just like adding Lego pieces, right? Without much of the hassle. So that was awesome, right? That was completely awesome. And now I'm looking here at socket. Okay, so sockets are one of the most interesting things that I really love, an exciting topic to me, and it's one of the fundamental of the internet. So to understand socket, let's going to imagine and we're gonna build a chat application with the knowledge that we have right now, and that is, well, making a HTTP post to send message or a get to read all of the message. The question is, how do we know when to fetch data? Because if we send a post message to our friend, perhaps he replied immediately after we send that, or a couple of hours later, or our friends perhaps is, um, or perhaps our friend is enjoying his life by doing things that are profane, that are against to the human nature, against the law, huh? Enjoying about that things called SAX. We don't mention that here, okay? Uh, but so he replied you a couple days later, right? Hey, what up, man? How are you, man? Sorry for not replying you. Fuck you. In any case, so how do we know when we fetch data? So the answer lies in sockets. So to answer this question, and it's important to acknowledge that this this answer is going to rely on data that we don't have control, that has been created by someone else, or that is in its own life cycle. Okay? So most of the time we often deal with this kind of situations quite effectively with something called polling, which is send a get request to your server so often in a period of time when that time has passed, send a new get request in a loop essentially. So I also saw is pseudocode here, okay, where we set is we use the server interval to send this post or read this information, okay. Uh, but that comes with some issues like when do we know to fetch, or when is the right period to fetch data? Is there even a right period? Doesn't depend how the data changed in the backend. How doesn't depend? Doesn't it depend how often this data changes on the backend? So with pooling, the best we can do is just good enough because, for example, adding 500 millisecond latency, it will add 500 millisecond delay for all of your update in your application. So for a chat app, might be okay, but what about the real stuff? For example, self-driving car, trading, or games. Okay, so even though for a chat app, which is in our case, might be okay, right? So we're sending is 2 requests per second. Multiply that by 60, you have 120 requests per minute. And this is just one single user. Imagine that you have 10,000 users. So, or you need a powerful server or a different approach. So sockets come to the rescue. But to understand what socket is an opening uh, or a hole or a hollow that form something. Or it's an opening or a hole. It's an opening or a hollow that can form a holder for something. So, for example, an electrical bulb socket, the eye socket. So a data socket is an opening in a computer system, and this computer is a machine, a programmable machine that performs logic and arithmetical operations automatically. And when we talk about computer system, is a computer with a computer including a hardware, a software, mainly a OS is the main software, and it is peripheral or or additional periphery, right? Such as, for example, you have a desktop, a keyboard, mouse, monitor, speakers, UPS, for example, uninterrupted power supply, you name it. So that's a computer system. So a data socket is an opening in this computer system that in which you can connect to send or receive data. So these connections are holder of the network computers. And the network computer is a set of computers uh, shared here, and a computer network, and a computer network, exactly. A computer network, a computer system. Mm-hmm. A computer network. So a computer network is a set of computers sharing resource located. Okay. So a computer network is a set of computers sharing resource located, or so it's a set of computers. You can imagine laptop or even your mobile. It's a set of computers uh, sharing resource located on or provided by a network node. And a network node is either a redistribution point or a communication endpoint, according to Wikipedia, right? So it's a redistribution endpoint, it's a redistribution point, okay, of sharing resource. These computers, a redistribution point of sharing resource, or a communication endpoint where he receives that. So this communication of data is what the internet is based on. So you have is the IP socket, which is the basic building block on the internet. On top of that, you have is the datagram socket or the UDP, where low latency is an important factor, or is the most important factor. Then you have the TCP sockets. Then you have the TCP sockets. They are connection based, so you need to connect before sending or receiving data, and they're also reliable. So when we send a message, you know whether the message has been received or not. And on top of the TCP sockets, which are connection based, it's reliable because you know when a message, you know. So when you send a message, knowing whether that message has been received or not. So when you send a message, you know if that message was received or not. TCP sockets. And then you have is the WebSockets and the HTTP. But the HTTP is a protocol on top of the TCP, okay, that is half duplex, whereas WebSockets are full duplex, meaning it allows communication, it allows two-way communication. And this is basically what the network sockets are, okay? So WebSocket is a JavaScript feature that allows the communication between the user browser and the server. And this is where the real power is. Okay? So here I'm looking is at sockets versus polling. So polling is using HTTP protocol to mimic a two-way communication. Right. Exactly. So sockets versus polling. So polling is using an HTTP protocol to mimic two-way communication, right? So sockets open a channel between, whereas sockets open a channel between the browser and the web server that allow real-time communication, or RTC. So by having this channel open, socket allows this way ongoing conversation to happen, right? By having this opening, this socket between between one computer system and another, okay? In this case, the browser and the server. This allows two-way ongoing conversation to happen. And implementation details will look like this. And it's basically this, right? Okay. Okay. Now let me explore is the so looking at sockets versus polling here. Mhm.
To date by emitting any new messages back to them. This means
Okay.
we'll see a lot more of this emit function when we start looking at our socket API and coding our multiplayer game. The key difference to note right now is that the server can in return decide when to notify the client of a new message by also emitting a message from the direction of the server to the client. The server can now decide exactly when to send a message back to the client without having to rely on the client making a request and asking for.
Exactly. This is so the server can rely on
When to send a message, emitting a message from the direction of the server to the client. The server can now decide exactly when to send a message.
exactly. So the server can decide when to send a message
Back to the client without having to.
exactly. So the server can decide when to send a message back to the client without without sending a without sending an HTTP without sending a GET request
Rely on the client making a request
or without relying on the client making requests
and asking for some information.
and asking for data.
In our sample front-end pseudocode from earlier, all of the front-end chat clients would be responsible for periodically fetching messages from the server using setInterval and this polling rate to continually make HTTP requests against our messages collection in our chat API. And by the way, we could make this pseudocode into real functional JavaScript just by making our anonymous function here async and then awaiting the promise that's returned from the fetch function. But rather than doing all of this unnecessary pulling of the messages collection, with sockets, our front-end clients only send or emit messages that we want to add to this messages collection here. The server is then responsible for keeping all of the clients, all of our front ends, up to date by emitting any new messages back to them. This means that the client now doesn't have to guess when a new message, like what's up, has been sent by another client that's connected to the same server. It means the server can send us these messages as they come in real time. And it means that we don't have to send thousands of GET requests, like we did before when polling, that might not actually result in any update to our data if no one has sent a message since the last time we made that request. This is a huge difference. This is revolutionary, and we're going to see it in action very soon to this messages collection here. And then awaiting the promise that's returned from the fetch function. But rather than doing all of this unnecessary pulling of the messages collection, with sockets, our front-end clients only send or emit messages that we want to add to this messages collection here. The server is then responsible for keeping all of the clients, all of our front ends, up to date.
It's important to know this. The server is responsible to keep the client up to date
by emitting any new message. The server is then responsible for keeping all of the clients, all of our front ends, up to date by emitting any new messages.
So the server is responsible to keep the client up to date by sending data
back to them.
By sending data when needed.
This means that the client now doesn't have to guess when a new message, like what's up, has been sent by another client that's connected to the same server.
Exactly. So the server doesn't have to guess. So the client doesn't have to guess. So the client doesn't have to guess when to fetch data when that changes.
It means the server can send us these messages as they come in real time. And
then let me look here.
Welcome back. We've seen how WebSockets change our chat flow from the traditional HTTP model, where a client makes requests against the server by polling it for new messages. Instead, with sockets, we have this bidirectional conversation between the clients and the server in real time. Now, let's start looking at how we can use WebSockets in Node before we dive into some coding very shortly. So how does this WebSocket feature compare to another protocol we've seen, like HTTP? Specifically, how does it compare in Node using Node packages? We now know that Welcome back. We've seen how WebSockets change our chat flow from the traditional HTTP model, where a client makes requests against the server by polling it for new messages. Instead, with sockets, welcome back. We've seen how WebSockets change our chat flow from the traditional HTTP model, where a client...
Chat flow, exactly. This website. Oh, come on, man, for real. Copy. Okay. We got it. Yeah. We have seen how sockets. Okay. We have seen how socket change the workflow chat model
makes requests against the server by polling it, change our chat flow from the traditional HTTP model, where a client makes
from a traditional HTTP model to WebSocket.
makes requests against the server by polling it for new messages. Instead, with sockets, we have this bidirectional conversation between the clients and the server in real time. Now, let's start looking at how we can use WebSockets in Node before we dive into some coding very shortly. So how does this WebSocket feature compare to another protocol we've seen, like HTTP? Specifically, how does it compare in Node using Node packages? We now know that WebSocket is a protocol, a way of sending messages over the internet, just like HTTP. And like with the HTTP protocol, we can have different implementations of how to get data from the server in different NPM libraries. Like for example, with HTTP, we have the Axios library or the Node Fetch library. Just like with HTTP, WebSockets can have different implementations in NPM libraries. The most common one in Node.js is the WS library, which provides the core functionality to use WebSockets in Node.js on the server side. And we can see, for example, and respond event, or the message event. And if we scroll up here to the a way of sending, like with the HTTP protocol, we can have different implementations of how to get data from the server in different NPM libraries.
In HTTP protocol, we have different ways to implement
HTTP protocol, we can have a way of sending messages over the internet, just like HTTP. And like with the HTTP protocol, we can have different implementations of how to get data from the server.
So just like an HTTP protocol, we have different ways to fetch data from the server
In different NPM libraries. Like for example, with
For example, exactly, just like an HTTP protocol. And this is crucial.
Specifically, how does it compare in Node using Node packages to another protocol we've seen, like HTTP? Specifically, so how does this WebSocket feature compare to another protocol we've seen, like HTTP? Specifically, how does it compare in Node using Node packages? We now know that WebSocket is a protocol, a way of sending messages over the internet, just like HTTP. And like with the HTTP protocol, we can have different
language HTTP protocol. So just like HTTP protocol.
different implementations.
Exactly. We have different implementations.
Of how to get data from the server.
Exactly. Different implementations of how to get data from the server
In different NPM libraries.
In different API libraries. For example, Axios. So Axios is our implementation of how do we get data from the server on a promise base.
Like for example, with HTTP, we have the Axios library or the Node Fetch library.
Or Node Fetch. A lightweight model that brings window.fetch to Node. In window, dot. And now we can rely on the fetch. This is a way of how do we send, how do we get data from the server? How do we communicate with the server?
Just like with HTTP, WebSockets can have different implementations in NPM libraries.
Mm-hmm. Just like HTTP, WebSocket can have different implementations.
The most common one in Node.js is the WS library.
Mm-hmm. The most common is WS library.
Which provides the core functionality to use WebSockets in Node.js on the server side. And we can see, for example, that we can create a WebSocket server by requiring our library.
Okay, so that'll be all for this video. And take care. Bye bye.